In this lesson, we will be looking at equations that are linear types of equations and being able to tell when we look at an equation whether it would generate a line when we graph it or not. So there are some rules, kind of, that have to be followed in order for you to know that an equation is linear. First of all, you can't have any exponents in it. So that means you can't have something like x squared, or you also can't have, and I know you don't know this as an exponent yet in your math career, but you also can't have like the cube root of x, because technically that is an exponent. You'll learn about that later. But if it's got something like that in it, you cannot, that is not linear. You can't have any variables or letters in the denominator, so you can't have anything that would look like this as part of the equation. You cannot have any more than two different variables in the equation, so you can have any combination of two letters or two variables that you want, but you cannot have an x, a y, and a z, for instance, or a b, and a c. You can only have two of those. And your variables cannot be written as multiples of each other. So your variables can't be multiplied like x times y or a times b or m times n or anything like that. Okay? So I have a whole bunch of equations here, and we are going to identify them as either linear or not linear. So what I'm going to do is I'm going to kind of drag these to the right category and talk about them as we go. Sometimes it's easier to pick out the ones that are not linear first and then go from there. So one of the things we know that cannot happen is we can't have exponents. So I'm going to go sort of through our list of rules. I can't have variables that have an exponent to them. So this equation right here, I'm going to drag. It is not linear because the x has an exponent on it. It is x squared, and that makes it not linear. This equation up here also is not linear because it's got that square root of x symbol with it. And that must have not come with it here. It's got the square root of x. I know that a radical does not seem like an exponent, but you will learn later on that that's actually x to the 1/2 power, although you don't know that right now. But know that when I say it, you can't have exponents, it also cannot be underneath a radical. Okay? And it doesn't look like any of the other equations have exponents. So now I'm going to go to my other rules. I cannot have any variables in the denominator. So that would make this equation not linear because it's got an x in the denominator. Some people think that this equation that's highlighted right now has a variable in the denominator, but really that's x over 1, so it's 3 over 4 times x over 1. So that variable, or that letter x, is actually in the numerator. So it does not have a variable in the denominator, so we're going to come back to that one. So that's the only one that has a variable in the denominator. Then you cannot have any more than two variables in your equation. So any two different variables. This one only has two variables, an x and a y. This one only has two variables, an x and a y. Some people think that this one has two variables because they see an x, and a y. But it's actually only two variables. There's two different ones, x's and y's, and I can actually combine that 4x plus that 5x to make a 9x. So it does only have two variables in it. This one actually only has one variable. We'll talk about that in a minute. This one has an x, a y, and a z in it, so that is not linear because it breaks that rule. And then this one has only an x and a y in it. This one only has an x and a y in it. So the one I just drug down there is the only one that's not linear because of having more than two variables. All right, then your variables cannot be multiplied together, so I cannot have an x times a y. So that would make this equation right here not linear because of the x times the y in there. All right, now we're going to go through all of the other ones, and all of the other ones are linear. This top one has no more than two variables. It doesn't have to have two variables, it just can't have any more than two. No exponents, nothing is multiplied, no variables in the denominator. This one is linear. This one we talked about having it look like there was more than two variables, but remember the 4x and the 5x can be combined to make y equals 9x. And so then there's no more than two variables there, no exponents, nothing's multiplied, no variables in the denominator. This one, again, it only has an x and a y in it. So two variables. There are no exponents, no variables in the denominator, and no variables that are multiplied together. So that one is linear. This one, again, it only has two variables, an x and a y. The x is in the numerator, although you might think it's in the denominator. And again, no exponents, nothing is multiplied together, no more than two variables. That one is also linear. And then the last one, x equals 7. I know it only has one variable in it, but that's okay. It just can't have more than two. It's okay if it has less than two. It just can't have more than two. So that one is also linear. So hopefully that helps you decide which equations are linear and which are not.